Hey there, so here we go with another example of using U substitution, or just using a change of variables as it's sometimes called. So we want to figure out the antiderivative of this, and again, if we think that U substitution might be an option, then what we want to do is we want to look for a function that is occupying the input of another function, and I see that this x cubed is occupying the input of this cosine. And additionally, what you want to do is you want to see, is the derivative of that function another function that's multiplying in the overall thing that we're trying to find the antiderivative for, the integral for. And so I see that if I were to do the derivative of x cubed, that would be a 3x squared. That's sitting right here, so yay, substitution, variable substitution can work for this. So I see that this is really the derivative of something that required a chain rule is what I'm realizing here. So here's how U substitution would work. We're going to let U equal the function that is occupying the input of this other function. So in this case, x cubed. And then you find its derivative. So that would be 3x squared. I noticed that that's this other piece. Perfect. So then what you do is isolate the du by multiplying both sides by the dx, so that I can see that this entire 3x squared piece right here matches all of this material right here. So all of that will get replaced with du. And then the x cubed that's sitting right here, well, that's going to get replaced with u. Okay, so here we go. So we're going to have the integral of the cosine doesn't get replaced with anything. Its input, the x cubed, is going to get replaced with u. And then the 3x squared dx, all of that matches now the du. So it just simplifies visually what we started with. We can see that this is actually a pretty easy integral to figure out. So the integral or antiderivative of just a cosine is a sine. And now our variable is u, so we have a u there. Of course, we have our plus c. And then we just want to return the u to its original x type function, which was x cubed. So we can see that the sine of x cubed plus c is our antiderivative or our integral here. And you might recall from an earlier video, I did the derivative of sine of x cubed to get this. In fact, it's right here. So we did this derivative of sine of x cubed to review the chain rule to see how we end up with this function here. So again, all that this is really doing, the change of variable, is really just a handy tool to help us see when a chain rule actually occurred and how we can reverse that entire process or reverse that derivative to get back to an original function.